Greek astronomers also thought that the best way to explain eclipses lunar era, imagining that the Earth and the Sun occupied opposite sides of the Earth and that the shadow of the planet, projected by the Sun, fell on the Moon and eclipsed it. A solar eclipse is apparently the result of the Moon passing between the Sun and the observer on Earth. Simulations and tests have been carried out that show that eclipses occur perfectly in this geocentric flat Earth model. But even today we wonder, is the Moon really the one that covers the Sun? Since this is not seen and there is no real image of eclipses from space or anything to prove it. A lunar eclipse arises from a shadow of the Earth, but it is a claim that is not really proven. This may sound strange, but let's see why, from a flat earthen perspective. During the full moon you can see how the entire disk shines brightly, an effect that is impossible from a spherical surface. If the surface of the Moon were dull and earthy instead of polished like a mirror, it might just look lit up like a wall, or like the face of a distant sandstone rock, but it might not glow brightly from all sides like the Moon does. We are going to see 4 important factors to know the true topography or shape of the Moon. The shaping factor. A shadow will always naturally move across different types of surface. The shadow will always take the shape of the surface or area, revealing the true shape of an object. This never happens on the surface of the Moon during an eclipse. The shadow diffusion factor. In a sphere the shadow is more diffuse around the edge. It is sharper or more defined in the protruding portion of the sphere. This is because the closer the shadow is to the light source, the more defined its edges will be. And the further the light source is from the shadow on the surface, the longer or more diffuse it will become. The shadow not only rises and falls, it stretches, bends with the surface and becomes sharper or diffuse. With these 2 factors you can know the topography or real shape of the Moon. But also the next factor is very important. The sine wave factor or S-shaped shadow. The Moon is supposed to be a sphere, the shadow that is projected on it must also take on the characteristics of a sphere. This critical factor never appears in lunar eclipses. The S-shadow is caused when a round, spherical or curved object passes over a spherical surface. As the shadow moves over the sphere, it adapts around its curve. The shadow will take the spherical outline and will always follow the nearby edges due to perspective. The shadow will take the shape, until it reaches the highest point. As the shadow passes the midpoint it begins to bend in a curved way. When a shadow moves across a 3D sphere, the center or the part close to the observer is the thinnest. The larger the sphere, the more the angle of its curvature will be noticeable. In the end you will always see the curvature. When we see any lunar eclipse we do not see that curvature or stretching or change in the sharpness of the shadow. In fact, every lunar eclipse looks like there is a disk moving through another flat disk, as seen in this image. As the circular shadow passes over the moon, it maintains its circular shape all the way without modifying its shape. It does not stretch, it does not distort, you do not see the S nor does it become sharper. These factors are enough to see that the moon is not spherical. But one more factor is missing to realize the surroundings of the moon. And that is the reflected light factor. A reflector does not cool down when you give it light and heat. The reflected light must be of the same color and properties as the origin, only the intensity or quantity must vary. This does not happen on the moon, it reflects differently and its light does not have heat, on the contrary its light cools. Temperature measurements have been made to prove it. The closer another object is to a sphere, the light it is reflecting will appear. During an eclipse, we are told that the moon is reflecting light from Earth, but does the Earth reflect light to the moon? If that were true, then the new moon phase would not exist, which is when the moon is not seen and disappears. If the moon were in total darkness, then it should be illuminated by the Earth, because that's when it's supposedly closest. But that of course does not happen. So the observations and experiments lead to the conclusion that the moon shines with its own light. It is not a reflector of the sun's light, but absolutely self-luminous. The Earth has been shown to have neither orbital nor axial motion, therefore, it could never come between the sun and the moon. According to the tests of the Earth, we live in a plane, always under the sun and the moon. Therefore, to speak of its interception with the light of the sun and to project its own shadow on the moon, is physically impossible. In addition to the previous difficulties or incompatibilities, there are many cases that recorded that the sun and the moon were eclipsed when they were both above the horizon, without being aligned with the Earth. This has occurred on different dates throughout history, phenomena that were recorded by astronomers and observers. The above, then, does not square with the idea that a lunar eclipse arises from a shadow of the Earth. Astronomers in the past have come to the conclusion that there is at least one non-luminous body of considerable magnitude that is connected as a satellite to this Earth. And there are invisible moons in the sky. This satellite is called the shadow object or antimoon. What makes eclipses possible only when the three bodies, sun, object and moon, are aligned, and when the moon crosses the orbital plane of the sun, at a point called the node. So a lunar eclipse occurs when the stark, non-luminous body passes before the moon, or between the surface of the moon and the observer on the surface of the Earth. The existence of dark bodies that revolve around luminous objects in the sky. It has been admitted by practical observers from the earliest ages, and that nowadays a great deal of evidence has accumulated on the subject. That astronomers are forced to admit that there are not only dark bodies that occasionally obscure luminous stars when they are in conjunction, but there are large cosmic bodies, and that at least one is connected as a satellite to this Earth. Many people who are not familiar with the methods for calculating eclipses and other phenomena tend to regard such calculations as powerful arguments in favor of the spherical Earth doctrine and Newtonian philosophy in general, but it has nothing to do with it. It is not difficult to form a general notion of the process of calculating eclipses. It can be easily conceived by prolonged observations on the sun and the moon. The lunar eclipse is a phenomenon that comes in patterns. By studying these patterns, it is possible to predict when the next transit or eclipse will occur. The astronomer can use historical tables with some equations to predict the weather, the magnitude and duration of a future eclipse. This also does not apply only to the eclipse. All recurring phenomena, such as transits of the planets, the concealments of bodies and the precision of the paths through the sky are predictable only because they are phenomena that come in patterns. Astronomers predict celestial events by studying the patterns and calculating when the next will occur. Actually, NASA freely admits that they use ancient cycle tables for their eclipse predictions. The Saros cycle and those ancient and dejected methods that simply look at past patterns in the sky to predict the next one is precisely how modern theorists predict the lunar eclipse today. The tables of the places of the sun and the moon, of the eclipses and of the related phenomena, have existed for thousands of years, and formed independently of each other by the Chaldeans, Babylonians, Egyptians, Hindus, Chinese, and other ancient astronomers. Modern science has had nothing to do with this, beyond making them a little more exact, averaging and reducing the fractional errors that a longer observation period has detected. But those predictions do not contribute to our knowledge of the causes of eclipses. And they don't allow us to predict anything that hasn't happened hundreds of times.